Okay, well, welcome back. We're going to be moving on to our next chapter, chapter 10. And in chapter 10, we're going to be working a lot with, once again, quadratic equations. We were involving quadratic equations, I believe it was back in chapter 7 when we did a lot of factoring. And now that we have a greater confidence and understanding of the square roots that we saw in chapter 9, we're going to see how we can now use those square roots to do other things. So everything that you learned in chapter 9 involving square roots will come back to haunt us in chapter 10. And what are some of those skills? Simplifying square roots, rationalizing your square roots, working with the imaginary number I. All of those ideas we will utilize once again in chapter 10. Because in chapter 10, we're going to take a look at, once again, solving quadratic equations, except we're going to use a different method. For example, we have already seen how to solve maybe x squared minus 81 equals 0. And we want to solve this for x. Recall, what we did in a previous chapter was we did some factoring. We recognize this as it was the difference of two perfect squares, and we were able to factor this. The factors of x squared, of course, would be x and x. We needed different signs, plus and minus, and of course factors of 81 would be 9 and 9. And now that we have a factored quadratic equation, recall we used the zero product property, and we would set each factor equal to 0. And then we would go and solve for x, and we got x equals a negative 9, and x equals a positive 9. And those were the two solutions to that quadratic equation. But let's say you're not a big fan of factoring. All right, maybe you forgot the difference of two perfect squares. You might want to have an alternative way to solve this particular quadratic equation. And now that we have knowledge of square roots, we can use what we call the square root method. So I'm going to show you this same equation and how we can solve it, not using factoring, but using this square root method. So let's say, for example, we have, once again, x squared minus 81 equals 0. Now, the square root method that we're going to be using here works because we have a squared quantity. Okay, here we have an x squared, that's a squared quantity, and we have this constant quantity of 81. And that's when we can use the square root method. And so what we're going to do is we're going to isolate, we're going to get the x squared alone. And to do that, I'm going to have to add the 81 on both sides. And now we would have x squared equals 81. But remember, what we are looking to do is to solve, of course, for just plain x, 1x. And right now we have x squared. Well, since we no longer want to have x squared, we want just x. What we're going to have to do to eliminate the x squared is to take the square root of the left side, and of course we know whatever we do on the left side, we must also do on the right. And here's the one thing that we have to remember. This is what makes it a little bit more difficult. Whenever you take the square root of the numerical side of the equation, you must put a plus minus sign in front of the radical. And so now, when we take the square root of x squared, we get just x. Plus or minus now, and when we take the square root of the perfect square number 81, we get 9. And so we get the same two solutions of a positive 9 and a negative 9 that we got when we did it by factoring. Okay, so this is just a little bit different in terms of our method. Okay, No longer factoring is required. Okay, if you are a fan of factoring and you recognize it as something that is factorable, you might want to use factoring. Or if you're not a fan of factoring, we have this alternative method now called the square root method, whereby first of all we have to isolate the squared quantity by bringing over the constant 81. Then once we have the x squared by itself, we have to eliminate the x squared by taking the square root of both sides. The key to remember is right here, that whenever you take the square root of the numerical side, you must put a plus or minus sign in front of that radical symbol. And that's how we get plus or minus 9. Let's try another example. Let's say we have x squared minus 49 equals 0. And once again, we want to solve for the values of x. And so we have here a squared quantity, and we have a constant quantity of 49. And when this happens, we can use the square root method, whereby I'm going to add the 49 over. That will now isolate the x squared, equaling the positive 49. And so now we can't have x squared, we want just plain x. So to just get x by itself, we're going to have to go and take the square root of the left side, and we have to take the square root of the right side. And since the right side we were taking the square root of a number, you must put plus minus in front of the radical symbol. When we take the square root of x squared, we get just x. Plus or minus, by taking the square root of 49, we get 7. So our two solutions that we would get are a positive 7 and a negative 7. All right? And that would be the same two solutions that we would get if we did it by factoring. Now, what if we had something like this? X squared minus 48 equals 0. Now, unlike the first problem, x squared minus 81 and x squared minus 49, those were in fact factorable, and you could have used factoring as your way of solving those quadratic equations. Well, let's take a look at this equation now. X squared minus 48. Well, this is not factorable. This is not the difference of two perfect squares. So we can't solve this by factoring, but it is still solvable. So we need an alternative method to solve this quadratic equation. And luckily for us, since we have a squared quantity of x squared, and we have the numerical quantity of 48, we could use this now square root method to solve this quadratic equation. I would of course begin by adding the 48 over to both sides. That would now give us x squared equals 48. And now since we don't want x squared, we want just x, I'm going to have to take the square root of the left side, and I will have to take the square root of the right side. And since I took the square root of a numerical side, I must put plus minus in front. And of course, when we take the square root of x squared, we get just x. Now, the square root of 48, 48 is not a perfect square. So we can't leave our answer like this. We have to, as always, like we learned in chapter 9, we have to simplify this radical. So we're still going to have the plus or minus, but now we have to think about how we can simplify the square root of 48. Well, we can use the factors of 16 and 3. And now since 16 is a perfect square, that's how we would get 4 square root of 3. So we are still getting two solutions. We have a positive 4 square root of 3, as well as we have a negative 4 square root of 3. Those are your two solutions to that quadratic equation. So here we didn't have much choice. We had to use the square root method because the original equation was not factorable. Let's do another one. Let's say we have x squared minus 20 equals 0. Once again, if we look at this, we have a squared quantity of x squared, and we have the numerical quantity of 20. Even though we are subtracting them, this is not the difference of two perfect squares, so this is not factorable, but it is still solvable, because what we can do is we can use that square root method. So I'm going to bring the 20 over by adding it to both sides. We would now have x squared equals a positive 20. And since we don't want x squared, we want x, I'm going to have to now go and take the square root of both sides. And once again, here on the right side, because I took the square root of a number, don't forget you must put plus minus in front of that square root symbol. And so now when we take the square root of x squared, we get just x. Plus or minus now the square root of 20. Well, just like the 48, the 20 is not a perfect square. So we're going to have to simplify the square root of 20. And I would use the factors maybe of 4 and 5. And since we take the square root of 4, that would give us now a 2 square root of 5. So our two solutions would be a positive 2 square root of 5, as well as a negative 2 square root of 5 would be the two solutions to that equation. Let me give you one to try. Once again, let's say we have x squared minus, let's say the number 100 equals 0. Take a moment, pause the video, give it a shot, and see what you can do as far as coming up with the solutions of that particular equation. Once you have solved the equation, come back and start the video again, and let's see if you got the correct answers. Well, here, once again, you did have a choice. There are two ways you can solve this quadratic equation. Maybe some of you recognize this as the difference of two perfect squares, and maybe you factored it into an x plus 10 and an x minus 10 equals to 0. And now we would set each of the factors equal to 0. X plus 10 is 0, and x minus 10 is 0. And we would get the two solutions that x would equal a negative 10 and x would equal a positive 10. So here we have the two solutions. Here we used factoring. But maybe you didn't recognize it as factorable. And since we have a squared quantity and a numerical quantity, we can go now and use the square root method. So let's take the same exact equation and let's use the square root method and see if we get the same two solutions. In which case we would have to begin by adding the 100 over. And so now we have x squared equals the number 100. And since we don't want x squared, we would have to eliminate it by taking the square root of the left side and the square root of the right side. And since we took the square root of a number, we have to put a plus minus in front of the radical. When we take the square root of x squared, we get just x equals plus or minus the square root of the perfect square number 100 is simply 10. And sure enough, we got the same two solutions, a positive 10 as well as a negative 10. So we get the same two solutions now using this square root method. So you'll get to pick and choose whichever method you feel is most appropriate when you are solving these quadratic equations. Once again, what allows us to solve using the square root method is the fact that you have a squared quantity and a numerical quantity. So you pick and choose. If you recognize it as factorable, you might want to factor it. If you don't recognize it as factorable, you might want to use the square root method. Let's take a look at another type of problem. Let's say we have x squared plus 25 equals 0. Now, this is not factorable over the real number system, okay? Because this is the sum of two perfect squares. And remember, when we talked about the sum of two perfect squares, we said that that polynomial was prime. But just because it's not factorable doesn't mean that it's not solvable. So here's what we're going to have to do. We'll still go and use the square root method. So we have to begin by isolating the x squared. So I'm going to subtract the 25 on both sides. That would now leave us with x squared equals a negative 25. Well, remember, we don't want x squared, we want just one x. So I will have to go and take the square root of the left side plus minus the square root of the right. Well, now let's take a look and see what's going to happen. Here on my left side, when I take the square root of x squared, we get just x equals plus or minus. Well, now remember, when we take the square root of a negative radicand, like we are here, the negative 25, that means we have to incorporate that imaginary unit. And when we take the square root of the negative 25, that's the same thing as taking the square root of 25 times the square root of a negative 1. And since we know the square root of 25 is 5, and the square root of a negative 1 is I, so now we would have two solutions. A positive 5i and a negative 5i would be the two solutions. Let's do another. Let's say we have maybe x squared plus 36 equals 0. Once again, this is not factorable. Okay, this is the sum of two perfect squares. But it is still solvable using, of course, the square root method. We begin by subtracting 36 over. And so now we would have x squared equals a negative 36. Since we don't want x squared, we want just plain x. I'm going to have to go and take the square root of both sides. And don't forget, when you take the square root of the numerical side, you must put a plus minus sign in front of the radical. Don't forget about that. A lot of students tend to forget the plus minus sign in front of the square root symbol. When we take the square root of x squared, we get just x. Plus or minus. Now we're taking the square root of a negative 36. Once again, since we can't take the square root of a negative 36 in the real number system, that's when we bring in the square root of 36 and the square root of the negative 1. And the square root of 36 is 6, and the square root of negative 1 is that imaginary unit I. So our two solutions would be a positive 6i and a negative 6i. Let's try another. One that's a bit more complicated. Let's say we had x squared plus the number 75 equals 0. We want to solve this quadratic equation. Now this is not factorable by any means necessary, and so that means we're going to have to solve it once again using that alternative square root method. We begin by, of course, subtracting 75 over. That would now give us an x squared on the left equaling a negative 75 on the right. Once again, we don't want x squared, we want just plain x. So I will have to go and take the square root of both sides. And when we take the square root on the right side, I have to once again put plus minus in front of that radical symbol. By taking the square root of x squared, we get just x. equals plus or minus. Now, once again, we have to simplify this radical as much as we can. The square root of a negative 75. I'm going to break that up into the square root of 25 times the square root of 3 times the square root of a negative 1. If we were to multiply these three things together, we would get the negative 75. The square root of 25, that's 5. The square root of the negative 1, that's I. We cannot do anything with the square root of 3, so we're going to leave that alone. So our two solutions would be a positive 5i square root of 3, as well as x would equal a negative 5i square root of 3. Let's try another. Let's say we have maybe x squared plus the number 40 equals 0. Why don't you try that one? Pause the video, solve it, and when you're done, start the video up again and check your solution. Well, once again, this is not factorable, but it is still solvable. I'm going to use that square root method. I begin by subtracting the 40 over. That would now give us an x squared equals a negative 40. To eliminate the squared on the x, I'm going to have to take the square root of both sides. And when I take the square root of the numerical side, once again, I must put plus minus in front of the radical symbol. By taking the square root of x squared, we get just x equals plus or minus. Well, now we're taking the square root of a negative 40. Let's simplify that. I'm going to use the factors of 4, 10, and the negative 1. So we're going to take the square root of 4, square root of 10, and the square root of negative 1. So all of these skills from chapter 9 are coming back. Let's see what we could do now to simplify these radicals. The square root of 4 is just 2. The square root of the negative 1 is I, that imaginary unit. Square root of 10, there's nothing that can be done, so we leave it alone. So our two solutions would be a positive 2i square root of 10 and a negative 2i square root of 10. And in all these problems, once again, we were able to use the square root method. What do they have in common? They all have a squared quantity, and they all have a numerical quantity. Okay, so look for that. That's something to look for and to indicate when to use that square root method. Let's try a slightly different one. Let's say we have a 3x squared minus 5 equals 0. Now this is not factorable, okay? So let's see if we can go and use the square root method to solve this for x. I'm going to begin by adding the 5 over, and that would give us a 3x squared equals the 5. We want x squared to be alone, and right now it's being multiplied with the 3. So I'm going to divide both sides by 3. And now when I do that, I'm going to have x squared equals the fraction of 5/3. Now, like we've been doing all along, we have to only get x by itself. We have to eliminate the square. So of course, I'm going to go and take the square root of both sides. I'm going to take the square root of the left and right, and because I took the square root of the numerical side, I have to put plus minus. So now let's see what we have here. Square rooting the x squared would give us just x equals plus minus. Now the square root of a fraction, that was something that we talked about in chapter 9. We had talked about that when you take the square root of the fraction, we take the square root of the numerator, over the square root of the denominator. We can, of course, leave our answer like this. Remember, never do we leave an answer with a square root or a radical of any kind in the denominator. So what we will have to do is to, of course, rationalize this denominator, which means I'm going to multiply by the square root of 3 over the square root of 3, just like we did in chapter 9. And so now what is x but plus or minus? If we take the square root of 5 times the square root of 3, that would give us a square root of 15. And remember, if we multiply the square root of 3 times the square root of 3, that gives us the rational number of 3. And that would be your two solutions. A positive square root of 15 divided by 3, and a negative square root of 15 divided by 3 would be your two solutions. Now, in all of these cases, once again, we had a squared quantity and a numerical quantity, and we were able to use the square root method to solve them. Let's take a look at another problem. Let's say we have x plus 3 squared equals 25. Now, I could have given you a problem like this back in chapter 7 when we first talked about solving quadratic equations. Remember, these types of problems required a lot of work, in that the first thing that we would have to do is FOIL the left side, in which case that would give us x squared plus 6x plus 9 equals 25. Now that we've FOILed the left side, remember, in order for us to solve a quadratic, one side of the equation always has to equal 0. And so, what we would have to do is subtract the 25 from both sides. When we combine our like terms, that would now give us an x squared plus 6x. The 25 is being subtracted from the positive 9, and that would give us a negative 16 equals now 0. So now we have created a quadratic equation that equals 0, happens to be factorable, so let's go to factor it down. Factors of x squared, x and x. We need different signs. And of course, the factors of a negative 16 that would add up to a positive 6 would be 8 and negative 2. And so now we would use the zero product property, and I would have to set x plus 8 equal to 0, x minus 2 equal to 0, and that's how we would get the two solutions of negative 8 as well as a positive 2. And that's what we did in chapter 7 when we looked at how to solve a quadratic equation such as this. It required a lot of algebraic steps to prepare our equation to solve by factoring. But what if we didn't want to use factoring here? What if we didn't want to use all of this algebra to get a quadratic equation ready? Well, let's take a look at the same exact equation. X plus 3 squared equals 25. Now, like the other problems that we did, where we had a squared quantity and we had a numerical quantity, we used the square root method. Well, let's analyze this equation. Once again, I have a squared quantity and I have a numerical quantity. So if I so choose, I could use now, once again, the square root method. What I'm going to do is I'm going to start by taking the square root of both sides. By taking the square root of the squared quantity, that will leave us with just the radicand of x plus 3 equals, now don't forget, when you take the square root of the numerical side, you have to put plus minus, and so now we have plus or minus, the square root of 25 is 5. But we don't want an x plus 3, we want just x. So to get x alone, we would have to subtract 3 on both sides. And that would give us now x equals, well, we have 5 minus 3, as well as we have a negative 5 minus 3, because that's what we have here as far as a positive 5 minus 3, as well as we have a negative 5 minus 3. Well, what is 5 minus 3 but 2? And what is negative 5 minus 3 but a negative 8? And you notice here that we get the same two solutions that we did when we used factoring as our technique. So even though we use a different method, we will not get different solutions. We should always get the same solutions regardless of whether or not we use factoring or whether we use, of course, this new square root method. Oops. Both methods work. Okay. Factoring only works when things are factorable. Square root method will only work when you have the squared quantity and the numerical quantity. Let's just try one more. Let's say we had x plus 8 squared minus 11, let's say, equals the number, let's say, the number 7. We want to solve this for x. Once again, I'm going to use the square root method. I'm going to begin by adding the 11 over. And so now we would have an x plus 8 squared equals, on the right side, 7 plus 11, of course, would give us the number 18. And so now, since I have a squared quantity equaling a number, I'm going to go and use this square root method, in which case I'm going to take the square root of the left side plus minus the square root of the right. Here now, on the left side, when we take the square root of the left side, we're going to be getting rid of that squared quantity, leaving us with just the radicand, x plus 8, equaling plus or minus. Well, the square root of 18, that's not a perfect square, but let's simplify. I will, of course, use my factors, 9 and 2, and when we take the square root of 9, we get a 3 square root of 2. But we don't want x plus 8, we want, of course, just x. So I'm going to subtract 8 from both sides. That would now give us x equals negative 8 plus minus 3 square root of 2. Those are your two solutions. Remember, you can't combine the negative 8 with the 3, okay, because the 3 has the square root of 2 attached to it, okay? So do not try to combine the negative 8 with the 3. Leave it in this form. So your two solutions would be negative 8 plus 3 square root of 2, as well as negative 8 minus 3 square root of 2. Those are your two solutions. Okay. That completes section 10.1. There is some homework that goes along with this. All right, so in 10.1, it was all about using this square root method as a way of solving your quadratic equations. Okay? If you're not a fan of factoring, or if something is not factorable, that doesn't mean it's not solvable. We just need an alternative approach, and the square root method gives us that new approach.